Good morning, dear students. Good morning, good afternoon, dear students.
Good afternoon, sir.
Good afternoon,
Good
all.
afternoon.
Sir.
Thank you for your good response. Now, uh, let's do the revision for the class. So, in the yesterday class, we have studied about the nomenclature of the various compounds. At the same time, we have studied about the structure of the carbonyl group. You can see here that if you look at the structure, we find that these compounds have a COOH group. Out of that, this carbonyl carbon, which is present in this compound, is not actually the carbon which is present in them is not actually so positive, and that is why it is less. It behaves as a less nucleophile, and due to that, the attack of nucleophile on this carbon is comparatively less if we compare them with the aldehydes and ketones. This is what it happens now. uh, let's move forward and understand the method of preparation. We can prepare them from the primary alcohols. In primary alcohols, if we allow them to, when it comes to the primary alcohols, if we allow them to react with the strong reducing agents, strong oxidizing agents, I'm sorry, like potassium permanganate or potassium dichromate, we can convert these alcohols into the carboxylic acids. When these alcohols are converted to the carboxylic acid, my dear students, uh, we can even use the Jones reagent, which is the chromium oxide at into the acidic medium. So by using the Jones reagent, even we can convert the very long chain of alcohol even to the carboxylic acid. You can see here one decanol is converted into decanoic acid. Same way, if you look at the um, other reactions, you can see butane one all is converted to butanoic acid. Even we can convert aldehydes into alcohol by the process of oxidation. So we use the tolerance reagent called ammoniacal silver nitrate and convert butanol to butanoic acid. From alkyl benzenes, my dear students, the chain present on the benzene, which if it is alkyl chain, however long it may be, it will definitely at the end will give us the benzoic acid. Even the chain is primary or secondary, it is converted to the benzoic acid. But if it is tertiary, then it is not affected by the oxidation or oxidizing agent like KMnO4 and other strong oxidizing agents. Same way, if the benzene is substituted, you can see here the benzene is substituted with COCH3 and methyl group. Both these groups are converted to the benzoic acid group, and we get benzene 1,4 dicarboxylic acid, or we call it terephthalic acid. If we have cyclic alkenes, then these cyclic alkenes can also be converted to the open chain carboxylic acid. The cyclohexane, if it is oxidized, it gives us the hexane 1,6 dioic acid, which is also known as the adipic acid. You can prepare the carboxylic acid from nitriles by the hydrolysis. On hydrolysis of nitrile, we get amides, and these amides on further hydrolysis gives us the carboxylic acid. If we keep the condition mild, if we have mild conditions, then the nitriles can be converted up to amide, and then amide should not be converted into benzoic acid. But you know that these amides on hydrolysis, they can be easily converted to the carboxylic acid. You can see ethanamide and benzamide, they both can be converted to respective ethanoic acid and uh, benzoic acid. Now today we want to study about the new process of preparation which is known as the process by which we can prepare carboxylic acid from the Grignard reagent. Grignard reagent reacts with the carbon dioxide, which is also known as dry ice. So it is in the solid state. This Grignard reagent, when it reacts with the carbon dioxide or dry ice, that is carbon dioxide in solid state, to form the salt of carboxylic acid, which in turn gives the corresponding carboxylic acid after the acidification with the mineral acid. So you can see here the reaction very well. Let me make you to see this reaction well. You can see I'm talking about this reaction, my dear students, that in this particular reaction, if you see, you will realize that we have the Grignard reagent RMGX. It reacts with the dry ice or it is solid carbon dioxide. It gives us the intermediate complex on which when we acidify it, this OMGX is converted to OH. And finally, what product we get is this, that this R, then we have C double bond O, and then here we get OH. This MgX is being removed, and this is how we can easily understand the preparation of carboxylic acid using the Grignard reagent. Now using the Grignard reagent, my dear students, we can choose this alkyl group, and on our wish, the alkyl group we choose, when we choose this alkyl group, on the basis of that we can get the carboxylic acid. So various types of carboxylic acid can be prepared by using the Grignard reagent. Grignard reagents and nitriles can be prepared from the alkyl halides. So, we can even prepare Grignard reagent from the alkyl halide. For example, if you have Rx, if you allow it to react with Mg in the dry ether, we get RMGX. the 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 surrounding or the atmosphere or the reaction mixture should be non-aqueous, or water must not be present during this reaction. Same way, my dear students, nitriles can be prepared from alkyl halides. If you are Rx and if you allow it to react with KCN, you will get RCN. So Grignard reagents and nitriles can be prepared from alkyl halides. You can see both the things we have prepared from the alkyl halide. Thus, using the method of Grignard reagent to carboxylic acid, we can prepare carboxylic acid having we can prepare the carboxylic acid having one carbon more than the alkyl halides. So if you have Rx, you can prepare Rm. Then from this RMGX, you add CO2 and you get RCOOH. So one carbon is added, and that is what it is known as the ascending series. So when you start with the alkyl halide which has 2 carbon, then you end up with the carboxylic acid with 3 carbon. So one number of carbon is being increased by this process, and this process is very well used for the various types of conversion. Now let's look at the example so that we can understand. This is the example I have taken from your exercise, my dear students. We have 3 nitro bromobenzene here. So you can see this is a 1 carbon, 2 carbon, and 3 carbon. So it's a 3-nitrobromobenzene. It is allowed to react with the magnesium metal in the presence of ether in the non-aqueous condition. We get Grignard reagent MgBr bonded to it. When we allow it to react with the carbon dioxide, my dear students, here in place of the MgBr, carbon dioxide is being added. So C carbon dioxide is C double bond O, C double bond O. So this C double bond O remains same, and here on this oxygen, this MgBr is being bonded, and then by the acidification, we get the final carboxylic acid. You can see here we have got 3-nitrobenzoic acid. So instead of the bromine group, we have introduce the carboxylic acid group, and this is how the alkyl halides or aryl halides can be easily converted into the corresponding or into the carboxylic acid which has one more carbon. Ascending of series can be started from alcohol to C as follow. We can even start from the alcohol. So benzyl alcohol, when it is allowed to react with HBr, it gives us the benzyl bromide. Then if you allow it to KCN, it gives us the C6H5CH2Cl. On hydrolysis, this can be converted to carboxylic acid. This carboxylic acid can also be represented in this form, and this is nothing but your phenyl ethanoic acid, because this is one carbon, this is second carbon. On second carbon we have um, phenyl group, so it's a phenyl ethanoic acid, or you can even write it as a 2-phenyl ethanoic acid. So this is how, my dear students, you understand the preparation of the carboxylic acid using either nitrile or either alkyl halide or grignard reagent. Now, my dear students, we want to study the preparation of the carboxylic acid using the acyl halides. These acyl halides are RCOCl. So if you have CH3COCl, you will call them ethanoyl chloride. Ethanoyl chloride. So if it is 3 carbon, then we'll call it propanoyl chloride. If it is more than one, then butanoyl or whatever. And if it is benzene ring, and then you have COCl, then you will call it benzoyl chloride. So this is how, my dear students, you give them the names to the various acyl halides. Acid chlorides, these acyl halides are also known as acid chlorides because they are prepared from the carboxylic acid. Acid chlorides, when hydrolyzed with water, gives carboxylic acid, or more readily hydrolyzed with aqueous base to give carboxylate ion, which on acidification provides us the corresponding carboxylic acid. You can see here, this is the acid chloride, which is also known as the acyl chloride. If you hydrolyze them with only water, they give you the carboxylic acid and Cl minus. But if you hydrolyze them in the presence of base, which is aqueous base, you can get the carboxylate ion. This carboxylic ion on further acidification gives us the carboxylic acid. So it's very easy to understand the change. You just need to remember that we can hydrolyze the acyl chloride with both water as well as with the base or aqueous base. Anhydrides, on the other hand, are hydrolyzed to corresponding acids with water. Now, if we have anhydride, suppose we have, anhydrides are the structures where you have the alkyl groups, and then these two carbonyl groups are bonded with oxygen, and this is how we get RCO twice into O. This is your anhydride. So if you have R is equal to benzene group C6H5, it is going to be benzoic anhydride, or you can even have benzoic ethanoic anhydride because you have uh, 2 carbon present on it. So it's a benzoic ethanoic anhydride because one side is a benzene group, whereas the another side we have methyl group. So benzoic ethanoic anhydride. Let us understand the reaction, my dear students, that if you have any anhydride, when it is hydrolyzed, it gives us the corresponding acid. Now, if both the R group are same, it will give us the RCOOH. But if both the R group are not same and one of them is R dash, then we may get RCOOH plus R dash COOH. So when both the groups are benzoic, we get, my dear students, benzoic acid. Here you can see that we can get this benzoic acid. But if both the groups are not same, then you will get two different acids. By using this 2 carbon, we get ethanoic acid. By using this uh, benzoyl part, we get benzoic acid. So from even anhydrides, we can prepare carboxylic acid, and we can prepare carboxylic acid depending upon the R group or alkyl group or aryl group present into the anhydride. From esters, my dear students, even we can prepare the carboxylic acids. So acid hydrolysis of esters give directly the carboxylic acid, while basic hydrolysis gives us the carboxylates or carboxylate ion, which on acidification gives the corresponding carboxylic acid. Even in 10th standard, my dear students, we have studied this reaction as a saponification. So if we have an ester, here we have ethyl benzoate. If we just do the acid hydrolysis, we can directly get benzoic acid and ethanol. So by the acid hydrolysis of ester, ester will give us the acid and alcohol. Please remember, my dear students, that on hydrolysis, the ester will give us acid plus alcohol. Same way, if you have ethyl butanoate, this is the ethyl pipe, this is the, so you can get the butanoic acid and ethanol, my dear students. Same way, let us look to the few questions so that we can understand it well. So how each of the following compounds can be converted to benzoic acid? First, we need to use the ethyl benzene. You know, my dear students, if benzene is having any alkyl chain, on oxidation with strong oxidizing agent like KMnO4, we directly get benzoic acid prepared from it. So we will allow this ethyl benzene to undergo oxidation in a strong oxidizing agent KMnO4 to get benzoic acid. Now if we have acetophenone, this is the ketone. Even this ketone on oxidation with KMnO4 will give us the benzoic acid. Oxidation with KMnO4 means very strong oxidation. That is what we can understand. Bromobenzene, if we have, then we'll allow it to react with the magnesium in the presence of ether. So my dear students, we will get the Grignard reagent, and this Grignard reagent with the dry ice, you can see, with this dry ice will give us the corresponding intermediate, and that corresponding intermediate can be converted to the carboxylic acid by the simple process of hydrolysis, my dear students. So by hydrolysis, this complex formed by the Grignard reagent will give us the benzoic acid. Suppose we have a styrene, this compound where benzene has got the side chain CH double bond CH2, which is also known as the phenylethene. You can see, my dear students, that here we have two carbon, one carbon, two carbon. If we put hydrogen instead of a phenyl ring, we will have CH2 double bond CH2, which is an ethene. This ethene, if it is a, if one hydrogen from this ethene is replaced by one phenyl group, we get phenylethene, and that is why this phenylethene is also known as the styrene, my dear students. So this styrene on oxidation with KMnO4 first give us the potassium salt of benzoic acid, and then on the acidification with mineral acid we get benzoic acid. So this is how, my dear students, we can convert the various compounds into the benzoic acid. Now, my dear students, we are going to study about the various physical properties of carboxylic acid. Let us understand the physical properties of carboxylic acid. Aliphatic carboxylic acids. Now, those carboxylic acids which contains alkyl group or which contain open chain, they are called the aliphatic carboxylic acid, my dear students. So here we are talking about the aliphatic carboxylic acid. Aliphatic carboxylic acid up to 9 carbon, remember, atoms are colorless, liquid and at room temperature with unpleasant odor. So please remember that up to 9 carbon, all the aliphatic carboxylic acids are liquid and they have unpleasant smell. The higher acids are wax-like solids. Please remember, the higher acids, that means the carboxylic acid having the number of carbon more than 9. They will be wax-like structure or wax-like solids. You can even call them semi-solid. They are not perfectly solids, but they are semi-solids or wax-like structures and are practically odorless. They do not have any odor due to their low volatility. They cannot be easily converted into liquid and they do not form the smell or they do not smell us anymore because of the low volatility. Carboxylic acids are higher boiling liquids. Now, why higher boiling? Because they have the hydrogen bonding that we are going to study in detail. So, carboxylic acids are higher boiling liquids than aldehydes, ketones, and even alcohols of the comparable molecular masses. So, my dear students, from this sentence, we realize that these compounds may have even more stronger hydrogen bonding as the type of hydrogen bonding found into the alcohols because their boiling points are even higher than the alcohols. This is due to the more extensive association of carboxylic acid molecule through the intermolecular hydrogen bonding. So these carboxylic acid, they have the intermolecular hydrogen bonding, and due to this intermolecular hydrogen bonding, the carboxylic acid are associated and this association makes their boiling and melting point little higher than it was expected. The hydrogen bonds are not broken even in the vapor phase. So even if you heat them and then let them go into the vapor phase, the hydrogen bonding present between the carboxyl molecules is not being broken and they even found in their vapor state. In fact, most carboxylic acids exist as a dimer in the vapor phase. So even in the vapor phase, my dear students, these carboxylic acid are dimer. Now, what is dimer? Dimer is the molecule that is formed by the two molecule of the same compound. So this is what it is known as the dimer. You can see here the one carboxylic acid is bonded to the another carboxylic acid by the hydrogen bonding. You can see here a clear hydrogen bonding formed and on the basis of this you can understand the dimer formed by the carboxylic acid in vapor state or in aprotic solvent. This carboxylic acid forms the dimer and they exist as a dimer. You can see, my dear students, a simple aliphatic carboxylic acids having up to 4 carbon atoms are miscible in water. Now, miscible means they can be dissolved in any amount. They can be easily soluble, dissolved, or they are highly soluble in water. So this is how we can understand about the miscibility of this carboxylic acid into the water. They are miscible in water because they form the hydrogen bonding with the water due to the formation of hydrogen bond with water. Now here in this figure, my dear students, you can see the hydrogen bond formed by the carboxylic acid with the water. You can see here, this is the water molecule. This is your H2O. This water molecule, this hydrogen has bonded a hydrogen bond with one oxygen of the carboxylic acid. This is your RCOOR. You have the hydrogen bonded to the another RCOOH, RCOOH. This is also your RCOOH. So you can see that a simple water molecule can make the hydrogen bond with three other molecule, or even more if it is if the alkyl chain is smaller. So hydrogen bonding of RCOOH with H2O, and that is why they can easily form the hydrogen bonding with the water, and thus they become uh, much soluble in water and they are miscible with water. The solubility decreases. You know, the solubility decreases with increasing the number of carbon atoms. So if the R chain, if the alkyl chain or if the aryl chain become longer and longer, if more and more carbons are added the to this chain, the solubility decreases because the long chain does not allow to form more hydrogen bonding, or the distance between the water molecule and the carbon chain and the next molecule increases and thus the hydrogen bonding decreases. Higher carboxylic acids are practically insoluble in water. So, my dear students, when the carbon chain become very long, or it's quite long that it does not allow the water molecule to form hydrogen bonding, and as they are, when the carbon chain is very long, uh, the carboxylic acid become practically insoluble in water due to increased hydrophobic interaction of hydrocarbon. So as the number of carbon atom increases, they form the hydrophobic part, and this hydrophobic part repel the water molecules, and ultimately they become insoluble in water. Benzoic acid, the simplest aromatic carboxylic acid, is nearly insoluble in cold water. So benzoic acid is almost insoluble in cold water. Carboxylic acids are also soluble in less polar organic solvents like benzene, ether, alcohol, and chloroform. So we can even dissolve this carboxylic acid into the less polar solvents like benzene, ether, alcohol, or chloroform. These benzene, ether, alcohol, or chloroform are also called the organic solvents. So these were the some of the physical properties. Even we are going to study more about their properties, but these were the physical properties. Now, my dear students, we are going to study about the chemical reactions of these carboxylic acids. First type of chemical reaction that we have is the chemical reaction that involves the cleavage of OH bond. First, let's look at the acidity. Reaction with the metals and alkalis. So when it comes to the reaction with the metals and alkalis, we know that when acid reacts with metals, when acid reacts with metal, my dear students, it produces hydrogen gas. So it produces salt and hydrogen gas. The same behavior we can even observe with the carboxylic acid, but the hydrogen gas produced is not so much, or you can say that these are the weak acids. So the hydrogen produced, but still being weak acids, they even produce the hydrogen gas. And let us see the reaction. The carboxylic acids like alcohol evolve hydrogen with the electropositive metals and form salts with the alkalis similar to the phenols. So same like alcohols and phenols, they even produce the hydrogen gas, and they even produce the salts of the metal. However, unlike phenols, they react with water or base, they react with the weaker base such as carbonates and hydrogen carbonates to evolve carbon dioxide. This is the speciality. This is not, this is what it is not done with the phenols and alcohols, but carboxylic acid. They produce carbon dioxide gas with carbonates and hydrogen carbonates, and this is how, my dear students, we can produce, or this is the test that we can use for the identification of the carboxylic acid group or COOH group, because this is the test which is not given by the by the phenols and alcohols. This reaction is used to detect the presence of carboxyl group in an organic compound. Let us see how does it works, or the chemical reaction for the test. We take two molecules of carboxylic acid, and if we allow it to react with the metal sodium, we get sodium carboxylate and hydrogen gas is produced. Same way, my dear students, if we have RCOOH and NaOH, then we get the salt and water produced. Same way, my dear students, when carboxylic acid reacts with NaHCO3, it produces carbon dioxide gas. So they even react with the base to produce salt and water. They even produce hydrogen gas with the metal, and they give carbon dioxide gas with the metal carbonate and metal bicarbonates. Carboxylic acids dissociate in water to give resonance stabilized carboxylate ions and hydronium ion. Let us understand this reaction. What happens there when these carboxylic acids are added to water, my dear students? When these carboxylic acids are added to water, these carboxylic acid, they produce H plus ion, So they are simply converted into two parts. One is your R C double O minus, another is your H plus. This H plus combines with water and gives us H3O plus. This RC double O minus, whatever we get, my dear students, this RC double O minus is resonance stable. So you can see that one oxygen which is having negative charge, the electron of negative charge, if goes to make the double bond, the carbon oxygen double bond electron goes to the oxygen and create the negative charge on it. So this is how, my dear students, you can see here the negative charge on carbon, on oxygen. So once if we call them as oxygen 1 and oxygen 2, so once if the oxygen 1 is having negative charge, in the another resonance structures, oxygen 2 will have the negative charge. Once there is a double bond between carbon and oxygen 1, in the second resonance structure there will be double bond between carbon and oxygen 2. And thus the oxalate ion, carboxylate ion is the resonance hybrid of these two resonance structures. So this carboxylate ion has got the resonance stability, and we can say that it is more stable, and as the carboxylate ion is more stable than carboxylic acid, it can easily donate H plus ion, and that is why it behaves like an acid. The same we can understand by using the knowledge of equilibrium. For the same equilibrium, we can, this is what I'm talking about. I'm talking about this reaction, that for this reaction, for the reaction between the carboxylic acid and water, we get the equilibrium established here. I'm talking about this equilibrium, and then we can write K equilibrium is the concentration of products, that is concentration of H3O plus and RCOO minus, divided by the concentration of reactants at the equilibrium, that is the concentration of RCOOH and H2O. But we are well aware, my dear students, that the concentration of water is considered unity and or constant, and that when we multiply these two constant, K equilibrium and water, we get the dissociation constant for acid, which is known as Ka. And for this equilibrium, we can write Ka is equal to H3O plus into RCOO minus divided by RCOOH, or the concentration of H3O plus ion multiplied by the concentration of carboxylate ion divided by the concentration of carboxylic acid. Dear students, here the EQ is known as the equilibrium constant, and Ka is known as the acid dissociation constant. For convenience, my dear students, the strength of an acid is generally indicated by the value of pKa value rather than the Ka value. So pKa is equal to minus log of Ka, and we generally represent the value of acid strength by the pKa value. More is the value of pKa, less strong is the acid, and lower is the value of pKa, more strong is the acid. The pKa of hydrochloric acid is minus 7.0, whereas the pKa of trifluoroacetic acid, benzoic acid, and acetic acid are 0.23, 4.19, and 4.76 respectively. So smaller the pK value, the stronger is the acid, the better it is as the proton donor, and stronger acid have pK values generally less than 1. The acids with pK value between 1 and 5 are considered to be moderately strong acids. So here, my dear students, we need to remember that more is the value of pK, less strong is the acid. Weak acids have pK value between 5 and 15, and extremely weak acids have pK values greater than 15. So this is how, my dear students, we can segregate the acidic character. Generally, the strong acids have value less than 1, and weak acids or very weak acids have value more than 15. If the value of pK is between 1 and 5, we consider them as a moderately strong acids. And if they are weak acid, then the value is ranging from 5 to 15. But very weak acid have the value, extremely weak acid have the value more than 15. So this is how, my dear students, we truly understand about the acidity of the carboxylic acid. Carboxylic acids are weaker than the mineral acids. These mineral acids are like HCl or HNO3 or they are H2SO4. So they are weaker than these acids because because they have carbon part which makes them weaker. But they are stronger acid than the alcohols and many simple phenols. For example, pK is approximately 16 for ethanol and 10 for phenol. So from this we can easily understand that they are stronger acid than phenol and alcohol. In fact, carboxylic acids are amongst the most acidic organic compounds. So we consider this carboxylic acid as the most acidic organic compounds that we have studied so far. We have already know that phenols are more acidic than alcohols. The higher acidity of carboxylic acid as compared to the phenol can be understood similarly by the conjugate base of the carboxylic acid. A carboxylate ion is stabilized by two equivalent resonance structures in which the negative charge is at the more electronegative oxygen atom, and that is why I have just explained you that due to the presence of these two carboxylate ions or two resonance structures which are quite stable, even the negative charge is present on the more electronegative oxygen ion. This carboxylate ion is more stable than the carboxylic acid, and that is why it can, this carboxylic acid is less stable. That is why it can easily produce H plus ion and we can get the carboxylate ion easily. So this is what, my dear students, today all I want to discuss with you. Now if you have any questions, you can ask me. Dear students, do you find anything difficult to understand? You can ask me so that we can discuss, or else we can move forward and do some required revision whatever we have studied today. बच्चों अगर माफ कीजिए, अगर आपको कुछ पूछना है तो आप पूछ सकते हैं.
नहीं पूछना है सर.
सब समझ में आ गया है. चलिए, let us revise. Today we have started studying the chapter from the preparation of carboxylic acid from the Grignard reagent. We know that using the Grignard reagent, if we add dry ice in the presence of dry ether, we get carboxylic acid passing through an intermediate. You can see here the various examples. We have taken the 3-nitrobromobenzene, then we have obtained the Grignard reagent, and on the reaction with the dry ice, we get 3-nitrobenzoic acid. Same way, my dear students, alcohols can also be converted to first alkyl halide and then are converted to nitriles, and on the hydrolysis, we can even get the carboxylic acid. The example is, if we take benzyl alcohol by reaction with the HBr, we get it benzyl bromide, and then with this benzyl bromide, we can produce benzyl cyanide, and this benzyl cyanide is converted to phenyl ethanoic acid. Same way, my dear students, we can even prepare the carboxylic acid from the acyl halides or acid chlorides. So acid chlorides on simple hydrolysis with water directly gives us the carboxylic acid, or by the basic hydrolysis we can get for the carboxylate ion or the salt of carboxylate ion on on acidification with mineral acid. Finally, we get the carboxylic acid. We can see here the various examples, like if we have the we can even produce the carboxylic acid from the anhydrides by the hydrolysis. So benzoic anhydride having two same groups will give us the two molecules of benzoic acid, but benzoic ethanoic anhydride will give us the benzoic acid and ethanoic acid. We can even form the carboxylic acid from the esters, my dear students. So uh, uh, esters on hydrolysis will give us the alcohols and carboxylic acid respectively. Let us look at the, once again I would like to share with you that if we have esters on hydrolysis, they will give us the acid and alcohol. So let's look at this. We have ethyl benzoate, my dear students. This ethyl benzoate gives us the benzoic acid and ethanol. If we have ethyl butanoate, that will give us the um, butanol and butanoic acid and ethanol. Let us convert, or we have even studied to convert the ethyl benzene to benzoic acid by oxidation with KMnO4. We have even converted acetophenone to benzoic acid by oxidation with KMnO4. We have converted bromobenzene into benzoic acid by allowing bromobenzene to react with magnesium in the presence of ether to get grignard reagent. And when this grignard reagent is allowed to react with the dry ice, we get benzoic acid. We have even prepared benzoic acid or carboxylic acid from the benzene which is having the alkene. So here we have the example of phenylethene or styrene. Phenylethene or styrene on oxidation with the strong oxidizing agent KMnO4 gives us the benzoic acid. We have, we have studied about the physical properties of these compounds, my dear students, that we have seen that carboxylic acid forms very strong hydrogen bonding, and as they can form strong hydrogen bonding among themselves, they have very high boiling and melting point as compared to even the alcohol, phenols, aldehydes, ketones, and uh, and the hydrocarbons. They can even form the hydrogen bonding with the water, and thus they are very much soluble into water. We have even studied, my dear students, that the first nine carboxylic acid, which have the number of carbon 1 to 9, these carboxylic acids are liquid, and if the number of carbon increases, the carboxylic acid goes solid or waxy solids, and they have this very long chain which is hydrophobic, and their solubility in water also decreases as the number of carbon increases. In most of the cases, even if we take them into the vapor phase, due to strong hydrogen bonding, this carboxylic acid even present in the vapor phase as a dimer, and that is what it shows, that they have very strong hydrogen bonding among them. We have seen that like other acids, carboxylic acids also react with metal to produce a hydrogen gas. Carboxylic acid even reacts with the base to give us the salt and water, and carboxylic acid even produce carbon dioxide gas when they are allowed to react with a metal carbonate or metal bicarbonate. We have even studied that the carboxylic acid, even when react with water, they produce H3O plus ion and the carboxylate ion. On the basis of that, we can determine the Ka value for the various acid, and then we can prepare the pK value. Even, my dear students, these carboxylic acid are weaker acids than the mineral acids like HCl, H2SO4 or HNO3, but they are stronger acid, or they are not very weak acid. From their reaction, we can understand that very easily. When we compare their pK value is the measure of their acidic strength. More is the pK value, less stronger is the acid, and thus by using these values of pK, we can say that strong acids or very strong acid have a value of pK less than 1. This carboxylic acid, uh, they have the value ranging from 1 to 5, or those acids which have the value ranging from 1 to 5, they are considered as a moderately strong acids. And then, my dear students, if the value is ranging from 5 to 15, they are considered as a weak acid. And if the value is more than 15, we consider them as extremely weak acids. So here, on the base of that, we can understand that carboxylic acids are weaker than the mineral acids, but they are stronger acids than the phenols and alcohols. And this is how we revise whatever we have studied today. Even if I would like to ask you, if you have any doubt, you can ask me here, or or you may go to the next class. Dear students, if you cannot understand anything out of this, whatever we discussed today, you can ask me, or you may go to the next class. Do you have anything to ask, my dear students? You can ask me, or you can move to the next class. बच्चों, अगर आपको कुछ पूछना है तो पूछिए, या फिर आप रूम छोड़ के जा सकते हैं अपनी अगली क्लास के लिए। कुछ पूछना है? प्रीति, अमित, वैष्णव, कार्तिक, निकिता, सुजल, मेहुल, भुवनेश्वरी, अंजलि। बेटा अंजलि, हाउ आर यू नाउ? कैसी है हेल्थ अब? अंजलि आप अब कैसी हो बेटा?
ठीक है सर।
ओके, प्लीज पे अटेंशन, और कुछ भी समझ में नहीं आया तो पूछना है बेटा तुरंत ही सर को स्टॉप करके। चलिए, विश यू ऑल द बेस्ट। प्लीज स्टार्ट लीविंग द क्लास and go for the next class, please.